this video, I'm going to talk about inferences again and SAT reading and writing science passages, particularly those really tough Module 2 problems, because I know that's what really most people struggle on. I've already covered SAT science passages in a separate video, which I'll put up here, but in this video, I'm specifically going to cover some Module 2 problems. And I'm going to talk about my strategies. They're very similar to what I would use on Module 1, but I'm going to be approaching these knowing that they're harder. And additionally, I'm going to cover the dual text passages, or when you have two texts and you have to use your knowledge to find a relationship between the two, compare the two in some way, and answer your multiple choice problems. So in this video, I'm going to go over first my tips for how I solve all these problems. I actually have a pretty easy step-by-step method that I use to solve, and it works very consistently. And after I give you that walkthrough of my method, I'm going to show you how I use it by solving a dual text passage, and then an SAT science passage with a graph or a bar, and then finally a passage that's just a single text asks you to logically complete the text. So with that said, let's go ahead and jump in and talk about that method and get into solving those example problems. So first off, when I'm solving an SAT science or inference passage, I'm going to read the question because this gives me an idea of what I'm looking for in the text. Make sure you use those annotative notes as you're reading to help you find relationships as you're going along. After reading that question, then go ahead and read the text. Doesn't matter if there's a graph or a chart for you to look at, go ahead and read the text. I suggest you start off with text 1 and then text 2 if you're doing a dual text. That at least is what has been what has worked for me. And as I already said, highlight, annotate as you go. If you're in an inference passage, I'd suggest you look for a relationship between variables, especially if you have a graph or a chart, because those typically ask you to find a relationship. Highlight any sentences that have like increase or a decrease or a direct relationship or inverse relationship in them, and highlight the researcher's conclusions, hypotheses, that type of thing that will generally give you an idea how to solve the problem, and have those key pieces of information highlighted so you don't have to go back, waste time trying to search for them. So after you've read the text and annotated, then it's time for you to either look at the graph or bar chart if there is one, and then formulate your answer. So you're going to use your knowledge of the question and the text in or graph and bar chart in order to form what you think a solid answer would be. And you want to have a pretty good idea, enough that you could explain it to somebody else. Explain that relationship, explain what kind of evidence would be used to support that researcher's conclusion, or something similar. Once you have that answer formulated, go ahead and go through the multiple choice questions and compare your answer to the question. And once you find the one that matches, you can go ahead and move on. Now let's go ahead and start off with solving that dual text problem, and then that SAT science problem with graph, and then finally that SAT problem with no graph, no dual text, just a single text, and trying to logically complete it. So here we have a dual text. I would approach this passage the same way I would really approach any of the other inference problems. Remember, if you are having a hard time with your time, especially on Module 2 reading and writing, generally hit the inference problems last, and I'd especially suggest hitting these problems last of all because they typically have the most reading involved. They're the longest. These two passages are actually fairly short. So first step is, of course, reading the question. Based on the texts, how would Barenfeld and colleagues from text 2 most likely respond to the conventional wisdom discussed in text 1? So there's conventional wisdom mentioned here, and how would Michael Barenfeld respond and colleagues respond to that conventional wisdom. So think about that as we're reading through the passage. I've done several different techniques trying to figure this out. For a while, I tried reading text 2 before text 1, and sometimes this works well, but especially if the concepts are very scientific and you're not very familiar with them, it typically works better to start reading with text 1. Ecologists have long wondered how thousands of microscopic phytoplankton species can live together near ocean surfaces competing for the same resources. According to conventional wisdom, one species should emerge after outcompeting the rest. Okay, so that's according to conventional wisdom for it there. So why do so many species remain? Ecologists' many efforts to explain this phenomenon still haven't uncovered a satisfactory explanation. So text 2. Ecologist Michael Barenfeld and colleagues have connected phytoplankton's diversity to their microscopic size. Because these organisms are so tiny, they are spaced relatively far apart from each other in ocean water and, moreover, experience that water as a relatively dense substance. This, in turn, makes it hard for them to move around and interact with one another. Therefore, says Barenfeld's team, direct competition among phytoplankton probably happens much less than previously thought. This whole sentence, I notice, is key, and it relates directly to the sentence above. That's going to help me formulate my own answer before looking at the passages. But Barenfeld is saying that conventional wisdom is wrong. The reason that one species doesn't outcompete the rest is because of how far apart phytoplankton are in the water, and that they don't compete with each other as much as previously been thought. That would kind of answer the question, saying, how would Barenfeld respond? Now let's see if one of the answer choices matches the answer I briefly outlined. A. By arguing that it is based on a misconception about phytoplankton species competing with one another. There doesn't seem to be a misconception here because direct competition is different than what was originally thought. So I would say this could be our answer, but let's go ahead and keep reading to make sure. By asserting that it fails to recognize that routine replenishment of ocean nutrients prevents competition between phytoplankton species. This is definitely not it. It pulls in information from outside the passage that wasn't even hinted to, talking about replenishment of ocean nutrients. Barenfeld doesn't cover this at all. By suggesting that their own findings help clarify how phytoplankton species are able to compete with large organisms. Again, Barenfeld doesn't talk about larger organisms at all. Not our answer. And D. By recommending that more ecologists focus their research on how competition among phytoplankton species is increased with water density. Again, this doesn't talk about water density, and this doesn't talk about what other ecologists should do. Definitely not our answer. If you notice, all three of the answers, B, C, and D, that were not correct went outside the passage. This is one of the key concepts when you're trying to solve dual passages on reading and writing module 2. Oftentimes they pull in information that's simply not mentioned. So make sure you read those texts thoroughly and you only pick the answer that covers material that's been talked about in those passages and doesn't go outside them. Okay, here we have an SAT science passage that has a graph. Just like other inference passages, let's go ahead and read the question. Which choice most effectively uses data from the graph to complete the statement? Now let's go ahead and read this paragraph below because that will help us be able to interpret the graph above. It's important to look for sentences that indicate relationships between variables for these passages because there's almost always going to be some kind of change in variables that you have to use in order to make an assumption or an inference. The population of the coral Lophelia produced a decline significantly around 9,000 years ago in the Albertan Sea. Okay, that's some kind of change of variable. Around 11,000 years ago, near the Mauritian coast, also declined. Use the ratio of manganese to calcium, which inversely correlates with ocean oxygenation levels, marine scientist Rodrigo da Costa Portillo Ramos and colleagues evaluated whether oxygenation played a role in the decline of El Portusa. Again, the researchers conclude that oxygenation may have been important in the Albertan Sea, but not near the Mauritian coast. So it says that, therefore, you're probably going to see some kind of change in oxygenation in the Albertan Sea, but not near the Mauritian coast. And again, here's some variables up here saying ratio to manganese to calcium correlates with ocean oxygenation levels inversely. So let me use a different highlighting color for that. So that would mean that a higher ratio of manganese to calcium would mean a lower amount of ocean oxygenation, or vice versa. So let's go ahead and look at the passage or the graph. We're going to expect to see a difference in the oxygenation or the manganese to calcium level for the Albertan Sea around 9,000 years ago, but no change really for the Mauritian coast around 11,000 years ago. Okay, so we look at the Albertan Sea, which is this black line here, 9,000 years ago, which is about right here. You can see that there's a increase in the manganese to calcium ratio this time, which means there's going to be a decrease in oxidation. So there is certainly a change. But if you look 11,000 years ago at the Mauritian coast right here, you can see that there's absolutely no change whatsoever. So this would seem to support the researchers' conclusion because the manganese to calcium ratio did change during this interval, but did not change for the interval for the Mauritian coast. So let's go ahead and take those ideas to our passage and look for an answer that matches those thoughts. A substantial increase in oxygenation in the Albertan Sea corresponded with the local decline in El Portusa. But the opposite relationship between oxygenation and El Portusa was found in the Mauritian coast. Well, we can see that there was actually probably a decrease in oxidation at this time at the Albertan Sea because of an increase to calcium ratio, because that's what an inverse relationship means. It's kind of opposite between the two. So we know that can't be it. There's also no change, like this passage suggests, near the Mauritian coast, so double not it. El Portusa declined in the Albertan Sea during a period of substantial local decline in oxygenation, but El Portusa declined near the Mauritian coast during a period of local little change in oxygenation. That's exactly what we see here. This increase in the ratio indicates a inverse decrease in oxygenation, but because it remains steady here for the Mauritian coast, there was really no change in the oxygenation. So that should be your answer. But let's go and keep going. Oxygenation in the Albertan Sea was higher before the decline in El Portusa than after the decline, whereas oxygenation near the Mauritian coast was relatively low both before and after the decline. Well, we can't really know how much actually was there, how much oxygenation was there. This is a ratio. It's not a quantity, and so it's kind of like we have a units issue going on here that doesn't make sense within the context of the problem. D. Oxygenation in the Albertan Sea tended to be substantially higher than oxygenation near the Mauritian coast during the period studied. Again, there's no relation. We don't need to compare Albertan Sea to the Mauritian coast. We're comparing these to the ratio which they're part of. This doesn't match up with researchers' conclusion. They're not comparing the two seas, but comparing the decline in coral in the seas to their oxygenation levels. So, whoops, that's not it. I meant to, there we go. So B is definitely our answer. I want to go ahead and pause right here before we get to our last passage, because I'd really encourage you to like and subscribe. It can help me as a high school student applying to college this fall get more people to engage with my channel and help me pay for college. And it's just very simple and easy for you. Please go ahead and hit that subscribe button. It helps me a lot, and it can help you get some pretty great SAT and college apps advice as well. So last question, this is one I consider also a science question, but it's your pretty typical inference question where you don't have a graph going on here. It's just a text, and you're supposed to most logically complete the text. Pretty easy question, so go ahead and read that text now. In a study of the cognitive abilities of white-faced capuchin monkeys, researchers neglected to control for the physical difficulty of the tasks they used to evaluate the monkeys. The cognitive abilities of monkeys given problems requiring little dexterity, such as sliding a panel to retrieve food, were judged by the same criteria as were those of monkeys given physically demanding problems, such as unscrewing a bottle and inserting a straw. The results of the study, therefore. So we can see in here some key phrases. The researchers neglected to control for the difficulty of the tasks. They give you an example of a task that requires little dexterity, and some that are very physically demanding. And so what happens when researchers neglect to control for certain variables? Their results of the study are going to be off. They're not going to be accurate. In a scenario where a monkey is completing a problem that requires little dexterity, then it's going to generally indicate that their cognitive abilities are higher than a monkey who is able to or is unable to complete a physically demanding problem, even if that's not necessarily the case. So let's look over here at the answer choices for something similar. A could suggest that there are differences in cognitive abilities among monkeys, even though such differences may not exist. That's kind of what I just said. Because you could have one that's unable to complete the physically demanding problem and one that's able to complete the not as demanding problem. Even if the monkeys really are just as intelligent as one another, it's a lot harder to do the physically demanding problem, and it'll make it look like there is difference between their abilities, even if there's not actually. So let's go ahead and keep reading. Whoops, I said that one is the right answer. B are useful for identifying tasks that the monkeys lack the cognitive capacity to perform, but not for identifying tasks that the monkeys can perform. Well, that's not indicated by the passage. It's evaluating their ability to perform all different types, but the researchers weren't trying to evaluate whether they could perform more difficult tasks or tasks that they lacked the cognitive capacity to perform. That's not what the results of the study were intended to present, and therefore doesn't have any effect on how they were skewed. So C should not be taken as indicative of the cognitive ability of any monkey species other than C imitator. This goes far outside the text. We're not talking about any other species monkey other than C imitator. Yes, it's an inference passage, but you are only using information that's given in here. If you've taken formal logic, they give you really the two premises, the two proofs, so to speak, that you use to create your conclusion. You use all the same concepts, but you just will organize them in a different way to create a conclusion. You don't bring in completely new concepts like other monkey species. This is not correct. Reveal more about the monkey's cognitive abilities when solving artificial problems than when solving problems encountered in the wild. This problem or passage doesn't talk about artificial problems versus problems in the wild. We can safely rule it out because, again, it goes outside of the text. I hope you enjoyed that video, and I hope it helps you to get even more of those Module 2 SAT reading and writing questions right, to save some time on those questions, because they're really what drains all that time away as you're working on the SAT, especially if you've gotten a harder version of the test. And so I encourage you to use these tips and tricks, strategies, methods in order to be able to solve these problems on exam day. So if you did enjoy my video and find it helpful, make sure you subscribe so you can check out my other videos, such as my reading tips video and my tips on what traps you should avoid for the reading passages. Those especially are really relevant if you're looking to get better with these inference problems, because they'll teach you some common traps that people fall for like almost every time, and avoid those. You're helping me pay for college by engaging with my channel, so again, please engage. If you have any questions, ideas for future videos, anything like that, please feel free to put those in the comments below. I'm always looking to hear from you guys. I'm always looking for more ideas because this channel is for you. So I hope you found the video helpful. Good luck on the October SAT or whatever you're taking your next SAT, and I'll see you again soon.